This Fleet Equipment Unscripted interview is presented by Hendrickson, a leading manufacturer of heavy-duty suspension systems and components to the global commercial transportation industry. Visit hendrickson-intl.com to learn more.
Hi everyone, I'm Jason Morgan, Content Director for Fleet Equipment, and welcome to Fleet Equipment Unscripted. Today we're talking with Shawn Whitacre, Senior Staff Engineer with Chevron. Shawn, it is great to connect with you. Thanks for taking the time.
Hey, thank you so much for the opportunity.
And really excited to talk today because we're going to talk about something that I think is going to become more and more relevant as the internal combustion engine evolves here, as we're all facing, fleets are facing increasing sustainability goals, reduced emissions, and we're starting to hear more about natural gas coming into the conversation, which has kind of been floating on the outside periphery there for a while. We have some hydrogen ICE engines coming down the line. So really wanted to connect with you, and we'll just kick it off here with all this evolution going on in the combustion engine space, including diesel, natural gas, hydrogen, those things. How is that impacting the lubrication of all those engine platforms?
Yeah, it's a very good question, and it's something I've kind of watched play out really over the past 30 years or so, because there's been a pretty drastic evolution in internal combustion engine technologies that really started back in the 70s with passenger car gasoline-powered engines to make them more efficient and lower polluting. So that means they got to burn less fuel and emit less emissions, and especially less harmful emissions. So as I mentioned, that journey started with passenger car in the 70s and started in earnest for heavy-duty diesel engines in the 90s. And we've seen something on the order of every 4 to 10 years a tightening of the emission legislation that has prompted changes in engine hardware that have had significant impact on the fluids that are used in these engines. Right. So that can be the fuel. We've seen a lowering of lead in gasoline and sulfur in diesel fuel, and many changes to the requirements that impact engine oils for all of these different types of platforms over the years.
Right. Let's talk about specifically natural gas. It's something I think the industry has some experience with, though it's kind of poised to change with some new natural gas engine platforms that will be available here soon and are starting to roll out in a test case scenario. But from your end, in terms of lubrication, how are those lubrication preventative maintenance needs and other maintenance needs different from what people might consider from a diesel engine?
Yeah, so I mean, there are some unique differences between the engine oils that are used to lubricate natural gas engines and those in diesel engines, and that derives largely from the type of combustion that happens in the two different types of engines. Whereas a diesel engine uses compression, ignition, diesel fuel, and natural gas engine operates in some respects a lot more closely to a gasoline engine where there's a spark ignition. It's a gaseous fuel in this case. And so that drives a different kind of combustion environment, temperature differences, different types of contaminants that can be derived from the fuel and that are byproducts of combustion that end up impacting the lubricant quality. And there's also different types of emission aftertreatment systems used in those different types of engines. Whereas in modern diesel engine, in fact, most engines these days have some type of emission control system, whether it be a passenger car gasoline engine that has a three-way catalyst, diesel engines today that have combinations of diesel particulate filters and selective catalytic reduction with diesel exhaust fluid. Okay. And modern CNG engines also use three-way catalysts to further reduce nitrogen oxides, hydrocarbons, carbon monoxide from their tailpipe emissions.
Right. Well, yeah, and as you know that too, then the selection of the oil and what you're speccing and putting in that engine can contribute to those after treatment. Well, I guess either avoiding some complications, right, on the particulate matter and build up in the DPF, or if you're choosing the wrong one, you can kind of add to your after treatment headaches there, and so that'll become a little bit more complex and different as we move to different engine and ICE engine types and different fuel systems, I'm guessing too.
Yeah, absolutely. So one of the key considerations for all of those platforms is the expected useful life of the emission control system. And regulators enforce that these not only meet emission regulations when the product is new, but for kind of throughout the lifetime of the equipment. And that has put increased emphasis on lubricant-derived contaminants. There's a small amount of lube oil that's consumed during the course of engine operation that ends up in the exhaust system, and over time can degrade the performance of whether it be a three-way catalyst, a diesel particulate filter, and SCR,
Right.
can degrade their performance to the extent that they no longer are compliant. And it's for these reasons that there have been limits placed and specifications that control the amount of things like phosphorus, sulfated ash, and sulfur in lubricants to kind of prevent that deterioration of their performance. For natural gas engines specifically, there has historically been a requirement to have lower sulfated ash. The amount of metallic additive used in a natural gas engine tends to be lower than that used in a diesel engine. And there's a variety of reasons, but namely it's because there are certain of those uncombustible materials that can accumulate in the intake valves, can foul the spark plugs, and then it can also create undesirable consequences in the exhaust system and degrade the performance of three-way catalysts that have kind of driven unique requirements for natural gas engines.
Right.
So another thing to kind of point out as it relates to natural gas engines is there really aren't any prevalent industry specifications. Whereas for diesel and passenger car engines, there's very robust industry standards that are developed and identify the performance requirements for those fluids. Since there are fewer builders of mobile compressed natural gas engines, it's really defaulted to particularly the Cummins engineering standards as sort of the de facto industry spec that defines the performance of these fluids.
Right. Well, and even then, I mean, going back to the diesel spec, even we've seen a shakeup in those standards over the past 3, 4, 5 years with the CK4, FA4, and FA4 not having as much adoption there on the front end. I personally, again, this is just personal feeling. I feel like we're going to start seeing those more, right? And even in the diesel world, fleets are going to have to start paying more attention to what the oil spec actually is and making sure they're getting that oil transition. The CJ4 to CK4 was kind of easy because it all kind of flipped, right? But going from CK to FA is going to be something to pay attention to. And if you move to natural gas or even down the line a hydrogen ICE engine, you're going to want to keep an eye and be really, really careful on what you're putting in that engine.
Absolutely. And that's why we always encourage our customers to look kind of more broadly at the requirements for a given piece of equipment, because it's important to not only understand the requirements in terms of the industry or OEM specification that defines what that product needs, but also the viscosity grade. So you mentioned a key difference that we've got on the diesel side now with the FA4 category, which defines, fuel economy, improving lubricants that are, unlocking emissions reduction and fuel and better fuel efficiency from diesel engines. And as I mentioned, just the unique requirements for natural gas engines that in some cases differ from those that govern the diesel products that a fleet might carry.
Right, for sure. You can't throw the 15 W40 in there and just call it a day. I mean, you really got to pay attention to what's happening here. And in that regard, on the Chevron side then too, how are you working with customers in trying to navigate all of this? And I mean, I know that you work closely in the diesel world and have on oil specs and oil analysis and that kind of thing. But what's your role as kind of the powertrain world changes?
Yeah, I mean, that's one thing that makes me very proud to work for a company like Chevron, because we're a global supplier of fuels, both liquid and natural gas, those that are derived from petroleum and renewable-based materials. We're also, a finished products supplier, so in engine oils and coolants and drivetrain fluids. But even behind that, we are a global supplier of high-quality lubricant base oils, and we have a wholly owned additive company. And kind of all that speaks to the versatility that we have as a company. We don't view this energy transition as a one-size-fits-all solution. I mean, our customers wouldn't tolerate that. we recognize there's differences regionally. There'll be differences over time that could be motivated by customer specific requirements, local regulation, fuel price, total cost of ownership considerations. And that's going to be an evolving landscape over time. And so what our customers can count on from us is to have kind of that right mix of solutions, and as well as the technical expertise, and to enable that partnership, which allows us to kind of figure out what makes the most sense for that given business and customer.
Right. Yeah, and to your point, and what I really want to highlight and make sure is really important here is what you're speaking to, I think, is the mix of solutions even one customer could have in a decarbonization strategy over the next 10, 15, 20 years. There's going to be a mix of diesel. There could be a mix of natural gas. There could be battery electric. There could be a whole host of things that you have to manage even more closely than maybe the diesel spec that you've kind of relied on over the past, right? Sure, maybe gear ratios have changed and efficiencies have changed, little things, but these are going to be things you're going to want to really study closely and understand for those segments.
Yeah, absolutely. I mean, it's about having the versatile product line, the product line knowledge, and kind of the breadth of technologies that can help meet that broad set of end user requirements. Because, as you mentioned, I mean, it's no doubt going to be a dynamic landscape as we move forward. And I think there's undoubtedly going to be some technological breakthroughs that unlock different challenges down the road. But it's been an exciting field to be in. I've been doing this for roughly 26 years, and the pace of change just really hasn't let up over that course of time. And everything that I've done, as a professional, has been with an eye towards more efficient, lower emitting products. And I'm just kind of proud to be, part of a large group of global stakeholders helping to drive that to completion.
Yeah, no, and I'm with you. I feel even in the past, even the pandemic notwithstanding, past 2, 3, 4 years, things have sped up exponentially. Yeah. And it is cool seeing the pace of evolution in the industry.
And it's happening all over the globe too, right? I mean, that's the big difference now.
That's right. Well, as we get to some of those more breakthroughs, I'm sure I will be calling you again soon to pick your brain on the best way to go and some strategies there. Shawn, I appreciate you taking the time. This has been wonderful. I will talk to you again soon.
All right. Thank you, Jason.